look at the example on the board. So what would be the temperature of 1 mole of a Vander Waals gas at a pressure of 9.50 atm contained in a volume of 2 liters? This is the Vander Waals constant A and the constant. So you must make sure that this A and B are in the right unit, okay? So they are in the right unit of Vander Waals constant. So quickly, we apply the equation P plus AN squared over V squared multiplied by V minus NB is equal to what? N ROT. Okay? So all the parameters has been given to you. This is the pressure, this is the volume, this is the A, this is the B. Take note, the universal gas constant you use here is 0.0821. Why am I using 0.0821? I am using 0.0821 because the pressure is in atm and the volume is in liter. Okay, so this is the right unit to use when you have these two things in the right order. So I'll quickly make T subject of formula, okay? So T will be equal to P plus AN squared all over V squared V minus NB divided by NR. Okay, so we can plug in the values, okay? What is P? P is 9.50 plus, what is A? A is 3.59 into 1 squared all over, what is V? 2 squared, 2 liters, 2. V is 2, okay? So 2 squared. Then you close this one, okay? Into what is V now? V is still 2. So 2 minus, what is N? N is 1. Bracket B. What is B? 0.427. Okay? So all these divided by, what is N? 1 times R, 0.0821. So if you take your time and punch this thing we have here, T will be equal to, having put all these values inside here and simplify. If you simplify everything inside that bracket, everything just like we have there, the final answer will become okay. Let's simplify everything here. Everything here will give us 10.3975. That is, simplify everything here and add it to this guy. You have this one, okay? Multiply by everything here will give us 1.9573. Okay? All over 1. 1 times this is still that same value, which is going to be 0.0821. So when you punch this expression, what you're going to get is 248 Kelvin. So this is the answer in Kelvin. So this is the temperature for this particular question. We are looking for temperature. Okay? So now, what about the next question? The next question, look at this next question. Calculate the pressure. Calculate the pressure of 0.25 mole of ammonia gas confined to a volume of 5.21 dm cube at 25 degrees C, assuming that the gas behaves as a real gas. Vander Waals constant A, Vander Waals constant B. So go ahead. P plus AN squared all over V squared into V minus NB is equal to nRT. So for the sake of this question again, we are still going to use R to be 0.0821. Why? Because the pressure is in atm and the volume is in dm cube. Okay? So go ahead. So how do you solve for pressure? We are going to make the pressure subject of formula. Okay? So pressure becomes nRT all over V minus NB. Take this one to the other side, minus AN squared over V squared. Okay? What did I do here? Very simple. I actually just made this pressure subject of formula by dividing this with this value and subtracting it with AN squared V squared. So I will plug all the values inside this place and that's the answer. So pressure becomes, what is our N? Our N here, okay, let me put it here. Our N here Number of mole is 0.25. So 0.25 times 0.0821 times temperature 25 degrees C, convert it to Kelvin, it becomes 298 times 298 Kelvin. Okay? All over V is still, what's the volume? The volume 5.21 minus 0.25 times Vander Waals constant B is 0.0371. Okay? Minus this one. What is the Vander Waals constant A? 4.18. Okay? Multiply by into 0.25 all squared. All over V squared is what? 5.21 squared. So please carefully watch all the values I put here. All these values you are seeing here is tallying with all these things you are seeing here. Okay? So that when you punch out this thing, the pressure becomes, if you press that stuff, you are going to have, if you press everything here, 6.11645 all over everything here, you will get 5.2007 minus, simplify everything here, you will have 4.1175 all over 27.144. Everything here, if you square this, you have 27.144. So if you simplify, work this thing out, work it out, the final answer to this question will be 1.0244 ATM. Remember, I told you that if you use 0.0821, your pressure will definitely be in what? ATM, since the volume was already in dm cube. So this is the answer to this question. The pressure to this question is this, while the temperature to this question is 248. So you can manipulate the Vander Waals equation just like the way I have done on the board here. It's quite simple. So look at them up, you'll see more questions to solve that will help you to understand properly what this topic is talking about.